Hey YouTube, welcome to Software Interviews, the ultimate guide to help you answer software engineering interviews. If you're preparing for software interviews, make sure to hit the subscribe button and turn the notification to never miss a video. Today we have this problem. Given a non-negative integer x, return the square root of x rounded down to the nearest integer. The return integer should be non-negative, as well as you must not use any built-in exponent functions or operator. For example, do not use bow in C++. I guess also in JavaScript we can't use it. And yeah, this is it basically. So how we can solve the problem? Actually, let's say that we have 1 minute. Okay, that's nice. Let's say that we have 9, for example, and the root of this one is 3. We all know that. So how we can find this 3 without using any tools in JavaScript like pow, something like that also? So one of the solutions that we can use a binary search. So basically we could take a binary search like 9, it will be like from right, and 1 it will be left, and we just find a mid. It will maybe like be 4, just 1 minute, sorry, it will be 4, okay, it will be 4, and we will try to see if this one equals the bow or not. If this is 4 multiplied by 4 equals 9, no. Okay, so we will assume this is not left anymore, and we will just try to search here. So this will be, this will be the new right, this will be the new left, and this will be the new right, and we will find another one like 1 plus 4, it will be 2.5. So it will be 2.5, and it will be 2 multiplied by 2 by 2, it will be 4, and 4 it's less than 9, and they'll say okay, so this will be the right, and this will be the left. Sorry, sorry. Two will be the new left, and we will have 2 and 4, and I guess we will have, if we put them, we will get 3. I will see if 3 equals multiplied by 3 equals 9. If this one, yes, I will return 3, and that's it. So let's just put this into code. I will say that let left equals 1. Okay, I could say let right equals x, but because of like all the time the round number is less than half of x, so it will be math.flow x plus 1. I would also let mid equals null for now, and I will make a while loop. Actually I will solve this one with binary search. Basically it will be time complexity of log.n. I'll say if left until left is less than or equal right, and I will say if nothing, and also read right. If we have number like 10 or something like that, that means that there is no square for it. So basically I'll return right directly. I'll say that let not let, I'll say that mid equals math dot flow left plus right divided by 2, and I will say that if mid multiplied by mid bigger than x, that means that we will right will equals mid minus 1. That means that we will start search for in this area instead of this area. Else if mid multiplied by mid less than x, I'll say that left equals mid plus 1, else I will say return mid. And I guess that's it. Yeah, that's it. Okay, so I will just make a small description. So basically what we have used here is a binary search. How we want to use a binary search all the time, we will just let's just delete all of that so we can understand. And while we're using a binary search, we find, for example, like an array or number or anything that we're searching in. For example, that we have an array. So basically the array, sorted array, because it is the easiest example that we will try to 0 1 0 1 2 3 5 and 7, for example. This is a sorted array, and maybe we want to find the target 5, for example. There is a way that we could solve it. We can find the target. It's just by looping through each element and compare the each and compare each element with the target, to say, does 0 equals 5? No. Does 2 equals 5? No. Does 3 equals 5? No. Does 5 equals 5? Yes. Return 5. And this takes time complexity of O of n. Okay. The binary search do something different, basically, because we don't have to loop through everything, because just let's say that it's a quite sorted, and so basically we can do that. We can just flip, take something called low. So this will be low, and this will be high, the last element, and we will try to and this will be the mid, and this is actually the mid that we are trying to find our own target by this mid. So basically we will say, okay, the low and the high, how we find the mid equals low plus high divided by 2. Okay, so I guess it will be equals to the 3. So basically we will say, okay, does this 3 equals the target? No. Okay, it doesn't equals. Okay, so we'll ask ourselves another question: does the 3 bigger or smaller than target? If the target, if this one is bigger than target, we will search only on the right side, because it's sorted. There is no need to search on the left side. If otherwise, we'll search only on the left side. So basically, if because it's the target is bigger than 3, so what we'll do, that we will search only on this side. So what we'll do, this will be the new low, and this will be the same high. The high will not change, and this will be the new mid. Okay, and what we're going to do is that we will say, if this mid equals 5, we will just return it. So basically, this is how the binary search work in a big picture. So basically, let's see what we have did. Actually, we have a number called 9. So basically, we just take a low and high. So basically, the low is be 1, or like and high, maybe like, let's say that left. I would like to make it low and high because it's easier. I will not when I say left and right, sometimes I'll get lost, and I will say the high will be 9. But however, because the deep root it's all the time less than half of the actual number, we should to go with 4 plus 1. It will be 4. It will be 5, I guess. Oh, sorry, just so okay. Let's assume that we only want to be with 9. So basically, we will get the middle. It will be 1 plus 9 multiplied by 2. It will be 5. So I will say is 5 multiplied by 5 equals 9. I'm asking myself if no. Okay, so if 5 plus not 5 bigger than 9, yes, 5 plus 5 multiplied by 5 equals all 5 squared, it's 25. So I only have to search in this area, and I don't have to choose any numbers here. So basically it will be the 5 so basically 5, it will be the new high, and we have this low, and we'll find another mid that will be, we have 1 plus 5 is 6, so we have 3, and I say if 3 multiplied by 3 equals 9, and yeah, it's it, and I'm returning 3. This is how actually we solve the problem, and here, this is how the binary search works. And I guess it's quite important to know how binary search works, because you will use it a lot basically in the interview, into most of a lot of coding interviews. I used it before a lot actually. And actually, I'll give you like a quick tip. Just make sure that when you are into an interview, to just have the same conversation with your interviewer, the same conversation I'm having with you right now, that I'm describing my solution, and also I'm just trying to clarify everything. Of course, you don't have to get as much detail as I'm getting in, because you only have 40 minutes or something like that. But you should make sure that you put your interviewer in the picture. You're not just going into code directly. You just describe, and you just tell to your interviewer, okay, this will take this time complexity, and maybe this I don't know if you prefer this or prefer this, and all the time ask for clarification, and all the time be like ask for the support of your interviewer, to make sure that you are working on this problem as a team. And yeah, that's it for today's problem. It will be time complexity of log.n, and I hope that you like it. And if you like it, I guess you could subscribe and hit the notification button so you make sure that you're not missing any videos. And also, if you we are making a new program that we put some sort of system design interviews into the future, but just so be ready about that basically.